So we are going to take a second look here at piecewise functions and how we go ahead and graph those. So as we did last week, we are going to take our two colors here and we are going to box our two inequalities with their restrictions in, because we want to be able to tell these apart as we're doing this. So when we go to graph, the first way we tackled it last week, well, the best way we're going to tackle it here, is to make ourselves some charts. And the way we determined how we were going to deal with the chart, there were two pieces to it. The first piece was, hey, what's the restriction? What's the inequality that's involved here? And we see here that for our red, it says x is less than -2. So we said, okay, that means we start at -2, and we needed a couple of more values. So if we're just kind of using our noggin for this, we kind of looked and said, hey, making ourselves a number line could be helpful. So if I started at -2 and I'm going less than, my next couple of numbers would be -3 and -4. And that's where we come up with our other values to plug in. Now, once I have my x values set, now I need to find y. We've talked before about how f of x is just a fancy way of saying y equals. And so all we're going to do here is we're going to take these x values and plug them in for x, and whatever comes out is y. So -2 plus 5 is 3. -3 plus 5 is 2. And -4 plus 5 is 1. And those would be the three coordinate points that I will be using to form my piece of this function. Now, before I just plot those, there's one more thing I got to watch out for that we're going to make. Yeah, if we're going to have an open dot or a closed dot. So quick reminder from last week. If it's just greater than or less than, that's going to be an open dot. If it's or equal to, going either way, that is going to be a closed dot. So for our red ray, I guess we'll call it here, are we going to have an open or a closed dot? Open. And I like to actually put that there just to remind me. So, -2, +3, open dot. And then I'm just going to plot the other ones. -3, 2, -4, 1. Always start from that first dot and connect from there. Because the direction of my arrow makes a difference. This says less than, go left. I want to make sure that my line does the same. And so then we do it one more time. Same starting point in this case, so -2. But this time, we're being told x is greater than or equal to -2. Greater than, we head to the right, to -1 and to 0. Okay, so having a number line may help. And now, same thing again. Now here, I want to be a little more careful. I might even decide that I'm going to bust out the calculator for this one. Because here, bless you, I want to make sure that as I'm plugging numbers in, especially with all these negatives, that I keep this straight. Because negative times negative is +4 minus 1. That's where the 3 is coming from. And so it doesn't hurt to get that extra little bit of assistance. Now the last one I think I can do. -2 times 0 is 0, minus 1 is -1. And again, they're just coordinate points. This time it's going to be a closed dot because of the or equal to. So lots of little detail things, and then we run into an interesting situation. -2, 1, 2, 3. You're like, well, wait a minute. That was an open dot a minute ago. That's okay, it's now going to become closed. That just happens. Does it happen every time? No, but it will happen some. -1, 1, 0, -1. Again, always start from your open or closed dot, because we should have one arrow going each direction. Now, typically with these, remember, when it asks if it's a function or not, it's saying, does it pass the vertical line test? Does it, if I start rolling through with a vertical line here, only pass through one point at each stop? And the answer is yes. Most of the time, our piecewises are going to be yeses, unless it's a very strange situation. And then, so the last part down here at the bottom, remember, is just asking me, hey, if I have this x value, what number comes out? So we go back to looking at our restrictions. Is 3 less than -2? Well, no. I mean, let's think about that for a minute. Is 3 less than... No. Is 3 greater than -2? Yeah. So we swing back to that expression where this is true and plug it in. Now again, I still want to know the answer, so either I use my calculator or my brain here, and I get that answer out. I look through here and I go, okay, x is -4. Is -4 less than -2? Is it further left on the number line? It is. I'd rather owe my friend $2 than 4. So I swing to that expression. Notice we're only plugging our number into one expression each time. We don't get to do both. We don't say, well, it's this one or this one. We got to make a decision. And so our last decision on number 1, f of -2. Ooh. Is -2 less than -2? No. Is -2 greater than -2? No. Ooh, but is it or equal to? Yes. So we're going to use that bottom expression for our last one. And sometimes it depends on the value they ask you. You might even be able to use your graph to figure out an answer. Like just for instance, f of -4. If I go to x is 1, 2, 3, -4, and go find the y value, oh, it's 1. Huh. Or if I go to -2, what's the y value? 1, 2, 3. So sometimes the graph can even come in handy for that when I'm trying to find my value. So for number 2, the only part we're going to do is the graphing, and I'm going to show you how you can use the calculator maybe to help you out. We'll see. And then you can kind of make a decision on how you want to deal with it. So one last one here. We'll do the same thing again. Box in your different lines so we're going to be able to tell everything apart here. So now this time, I'm still going to make my chart, but I'm going to let the calculator help me out a little bit. I know I'm starting at 1. I know because of the or equal to, that's going to be my closed-in dot. So if I want a little help, or a way to make this possibly go a little faster, we'll see. We're going to go to y equals. We're going to type in our equation to x. Again, the x button's always next to that green alpha, plus 1. And we're going to pull up the chart, which is second and graph. So I'm going to go down to 1. And I see the y value is 3. So I might as well take advantage of that. And here's the one decision I have to make. X is greater than or equal to 1. So now I got to decide, do I want the 2 values below it? Or do I want the 2 values above it? Okay. Well, if I think about it, x is greater, it means the numbers are getting bigger. So I want 2 and 3. And then I can just grab the numbers straight from the chart. Not a huge difference. It's not like it's some miracle thing that's going to just tell me all the answers, but it does help. 1, 3, closed. 1, 2, 1, 2, 3, 4, 5. And 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, so if the little equations aren't your favorite thing, that's one thing we can fix. And then we do the same thing on the next one. Again, I'm still going to suggest, even if you're using the calculator, that you still use the chart, just so we can see what's going on here. So if we go back here, we clear that out. Reminder on the calculator, if we ever have fractions, we need to use parentheses. Otherwise, we're going to get some weird looking stuff. Okay, I'll still even hit graph on this one. I just want to make sure it's a line. It is. Okay, nothing funky went on there. That's good. So here, let's see. So we're starting at 1. Negative 2.5. Okay. X is less than 1. Less than means I'm going to go to the values that are less, which would be 0 and negative 1. So we'll get those. Again, I can get the same thing, plugging them in or using any calculator. I don't have to have a graphing calculator to do it. So 1, negative 1, 2.5. We just kind of guesstimate a little bit. Sure. Huh? Excuse me. 0, 1, 2, 3. And negative 1, 1, 2, 3 and a half. Always start from my open or closed and work my way through. So either way, as far as the graphs go, they're going to help us. And again, the plugging in of numbers would be exactly the same as it was with our other problem.